hope I can start. With a picture that Stella T took at her house of a house finch, which appears to have a brown mutation. And what's interesting from my point of view, well, first of all, here's a regular female house finch to compare. You can see the same body shape and so forth, and a little bit, let's see, get the pen going here.
Are you not doing windows?
We can see that there's a little bit of striping on the belly.
Right. I'm trying to get the pen to work. Hold on one second. Oh, I know.
Yes,
So you can see the stripes.
yes.
I meant to get the laser pointer going. Let's see where that. Let's try it. Wow.
It could be a male too. It's hard to see enough markings to rule out that there might be red there if it weren't present.
But the red wouldn't go away with the brown mutation.
It wouldn't go away.
It wouldn't go away. So I think it's the brown mutation, but haven't really. Well, that's what I think it is anyways. And just, let's see, what can I get this to work? Just by coincidence, Nathan and I independently took pictures of this Carolina chickadee last winter at Sycamore Landing and wrote up a little article about the brown mutation. So
Hello?
Yes,
I think you might have to silence that.
yes.
So you can go to the Montgomery Bird Club website, and we have a little growing section on ornithology, and it talks about colors and color mutations as well. There wouldn't be the brown mutation if the red were gone too, but I think they'd have to be more white. So I'd have to review that. Here was a very lovely picture of a purple finch by Karen Sear,
Yeah.
their house. I like this picture of the swamp sparrow by our illustrious president at Red Gate Park.
Nice.
Another picture by Karen's of a brown creeper. I personally can never get a good in focus picture of a brown creeper. I think it's got some sort of anti-photograph camouflage system or something. It's a lovely one. Well, winter's approaching, I guess, and here's some, I forget how many, 1, 2, 3, 4, 5, 6, 7 white-winged scroters by Jim Ivet at Little Seneca Lake. One day wonder. I happened to be walking and came across a bunch of crows mobbing this juvenile light morph red-tailed hawk, and I happened to get all of the crows. There are only 3 in the picture with the hawk.
That's great.
They were flying around for a while till it took off. But here's another picture by Stella of a merlin with something. Do you know what? Anybody know what this something was or is? Life in action.
No, no.
Here's a picture of a great blue heron who caught a frog. I guess that's a bullfrog. I'm not sure. Great blue heron at Cino Canal, at Great Falls. For a few days, we were treated to cattle egrets that Jared Fisher had found up on along Germantown Road. They seem to be hanging out in regular yards, although there was, I guess, some farmland or ranch land behind, but they spent a lot of time just in the regular lawns. And who cannot see enough? Who can see too much of wood ducks? So, Pretty Wood Duck by Mark Ross. This was at Riley's a week ago. Another maybe sign of winter is Ross's Goose by Nathan T. that was at Lake Hollowell for what, I don't know, 4 or 5 days maybe. So many people got to see that. And finally, An Eastern Towhee by Chris Wright. I always fall for this bird. I think it's really pretty. So thanks for all the pictures people are submitting to eBird. It's great.
Thank you, Scott.
Okay. So now for the November edition of Bird Science Tidbits. This was brought to my attention by Dave Roberts. So I have him to thank for this. The word for the day is Parthenogenesis, from the Greek Parthenos, or virgin, and genesis, creation. The natural form of asexual reproduction in which growth and development of embryos occurs without fertilization by sperm. In animals, parthenogenesis means development of an embryo from an unfertilized egg cell. Some invertebrates, more often than fish, amphibians, and reptiles, show this, and they in turn more often than birds, although it has been described in domestic chickens, turkeys, and pigeons, but none have been known to hatch in nature. Again, in mammals, none known born alive in nature either. And part of the reason is that you need paternal genes for proper placental formation.
What about in marsupials then, I wonder?
Probably the same thing.
They don't
I
have
assume,
placentas though, of course.
well, that's true. Yeah, I don't know. That's a good question. Well, you can tell us next month if you find any.
I'll look it up.
Okay. Okay, so in species that use the XY sex determination system, like mammals and marsupials of mammals, the parthenogenetic offspring will have 2 X chromosomes that are female. In species such as birds that use the ZW sex determination system, the offspring genotype may be one of ZW or female, the ZZ of male, or WW, which is non-viable in most species. So here's the one of the newspaper articles. This is in the Washington Post, where they said that California condors nearly went extinct, now capable of reproducing without males. I think people got maybe more excited than they should have, but anyhow, it is an interesting event. Condors were originally covering a wide area of the West. You can see in the pink shaded part of this map. But they reached a low of 22 condors in 1982. But over 1,000 chicks have been born through captive breeding, but from only 14 founders. By 2019, 535 condors were known to be alive, about half of them in captivity, and the rest in the wild. Genetics has been used to track diversity. Since they started from 14, they want to know how much inbreeding there is and maybe try to connect that with the fitness of the birds that they're following. Here's the original article that's referenced in the Post article, and these are people that work through the San Diego Zoo Wildlife Alliance. Articles by Oliver Ryder et al. So what about this parthenogenesis? A female laid an egg giving birth to a live male. This happened again with another mother. The genetic analysis showed only maternal DNA, and both mothers, who represent 2.4% of reproducing females, were cohabitating with fertile males. And they did have offspring with these males as well. both of the offspring were relatively small and died before becoming sexually mature at 1.9 and 7.9 years old. And condors can live into their 50s. So what's the significance of this? So this is just an example, a rare example in birds of facultative reproduction. In other words, just asexual reproduction from a species that can normally reproduce sexually. These represent incidental findings in the captive breeders. So since they were following the fitness of the condors, they were genotyping and studying the genes of most of the condors that were born. In fact, they'd studied 911. And in 2 of them, they found that the DNA from the offspring matched the mothers, and there was no paternal contribution. So it's not that common, obviously, 0.2% or so. Question also is, does this occur in the wild? All current condors are descendants of 14 individuals. So the bottleneck that they went through did not apparently lead to an increase in parthenogenesis. None of the 14 were found that way. There doesn't seem to be any sort of pressure to increase parthenogenesis when there is a bottleneck. So we also don't know if other birds can do this because this hasn't been studied with modern genetic techniques. We don't go around and genotype hundreds or thousands of any type of species. And you'd have to have the mother as well. So you'd have to have the pairs. I'm not sure if it's ever going to happen. You'd also have to find, they'd have to be fit, and they may not be fit as well. So although this is an interesting finding, it's probably not relevant to the survival of any species or the continued reproductive success.
Well, given the lack of fitness of the 2 offspring, it suggests, since they wouldn't have bred successfully, that any tendency toward it in this population would never grow because they're not surviving to breed.
That's right. That's right.
Though I think one of them died due to an injury, not just because it was sickly.
Yeah, I think it had an infection in its foot and it didn't heal. But it had, one of them was had some skeletal abnormalities, so they weren't quite right. And I think there's only I think it was some pigeons that actually gave birth to viable offspring that later reproduced, and that was only a couple of examples. Okay, so let me stop that.
I'd like to go back to parthenogenesis. Parthenogenesis is really quite common in insects, particularly small parasitic insects. And they can go many generations without any males being present. And probably that's the biggest group that carries out parthenogenesis that I'm aware of. Yeah, almost every not all, no, I shouldn't say that. Many parasitic wasps are all produced by parthenogenesis. Yeah, so.
Yeah. Well, it's amazing what nature can do with,
Yeah.
all different directions.
Yeah.
Thanks for that.